today we're going to take a deeper look into the phases of matter. And you've talked about, or we've discussed the phases of matter and the different properties of each phase. For the purposes of this class, we're going to focus on the three basic phases, and those are solids, liquids, and gases. And from that discussion earlier, we know that solids, they have a distinct structure. The molecules are aligned in an arrangement. Some of those arrangements can be pretty cool. When you look at crystalline structures, or the structures, the arrangements of the molecules that make up crystals, those can be in a whole variety of different geometric shapes. They can be pretty cool. So those crystals that you find out in nature, that's what's going on. That's what gives them the shape that they have, is the structure, the arrangement of those molecules. As we look at the other two phases, those are our fluids. Keep in mind, a fluid flows. So if those molecules are able to flow, they're not in a specific arrangement, they're able to move around relative to each other, then it's a fluid. Our first fluid is the liquids. Liquids have movement between molecules. They're not solidified into a specific structure. And so the fluids will take on the shape of whatever container that they're in. Gases, on the other hand, gases are... there's a lot more space in between those molecules. The molecules are moving around. There's a lot more space. And so we have a lot more speed when we compare those gases to the liquids. All right, so let's take a look at what happens as we change from one phase of matter to another. And that's our whole focus for today. So we have specific terms for when we change from one type of matter or one phase of matter into another. The one that most people are familiar with, and when you think about changing from one phase to another, changing from solids or liquids or gases, most people think about water, because water, it's easy to think of water as either a solid, ice, a liquid water, or a gas, water vapor, that's in the atmosphere. So we're going to use water as our example throughout this short video. So here we see gas. When water is in a water vapor state, that phase, the gas phase, if it is going to change from gas to a liquid, we call that condensation. We see we have this arrow here that's pointing from gas to water. When matter goes from gas phase to a liquid phase, that's condensation. When it's going the opposite direction, when it's going from liquid to gas, that's what we call evaporation. So those are the terms for changes between gases and liquids. The other thing that a lot of people, the other concept really, of changing matter with water is going from ice to liquid water and back. All right, those are other common terms that people already know. So when we're going from liquid to a solid, then we call that freezing. When we're going from solid to liquid, then that's melting. All right, so with gas to liquid, we have condensation and evaporation. Between solid and liquid, we have melting and we have freezing. The terms that a lot of people aren't really familiar with are those changes that go directly from solid to gas and from gas to solid. So here, if we're going from solid to gas, then we call that sublimation. If we're going the opposite direction, if we're going from gas to solid, right here we call that deposition. So those are the terms whenever we're changing from one phase of matter to the next. Those are the terms that we'll use. So let's look at those changes and what causes the change. The biggest change, the biggest cause, the driver for that those changes is energy. With solids, you have those molecules in a fixed structural state. There's not a whole lot of motion. There's not a whole lot of energy that's being used. And so as we have low heat energy, then our matter is going to be in a solid state. Think about what does it take to turn water into ice, liquid water into solid ice. You lower the temperature. You decrease the amount of energy that is possessed by the water. And so as we increase heat energy, what we will see is the temperature of that substance will increase until it reaches a specific point. And at that point, that's where melting starts to happen. And it's kind of funny, and you would think that the temperature would just constantly go up. But what happens at the melting point, that's what we call that point where the solid becomes a liquid. As we increase the temperature, we have a leveling off, a plateau that happens as that solid is changing into a liquid. We have the same thing going the opposite direction. As a liquid is changing to a solid, as it is freezing, we have a plateau as the energy is changing. So over here, as we have the liquid changing into a gas, again, we have an increase in temperature. The temperature of that substance remains constant as it's changing from liquid to gas, from solid to liquid, or any direction that it's going. We have that plateau as the liquid boils or as the gas condenses. All right? Boiling is the same as evaporation. All right? So, the boiling point is where water begins to evaporate into water vapor. That liquid evaporates into a gas. And then our last phase change diagram. All right, this is what a lot of people call the triple point diagram. And we have the three phases, and this one is using water as an example. We have the three phases of matter. We have solid over here. We have liquid up here. And then we have a gas down here. And notice the different variables that go into these changes that are occurring with water. We've already talked about temperature and what effect temperature has on the change of matter, or the change of the phase of matter. Here we're going to add pressure, because temperature and pressure determine which phase that substance will be in. So here with water, with atmosphere at, or the pressure that we feel from the atmosphere at sea level is what we call 1 atmosphere. So 1 atmosphere is right here. Now, temperature down here, keep in mind we use Celsius instead of Fahrenheit. So with Celsius as our temperature, as temperature increases, we have the change in the matter that we saw, or change in the phase that we saw with the last diagram. All right, starts off as solid, moves to liquid, and then to a gas. Now, the thing about the triple point is that it works in the variable of pressure. And so, as we increase pressure, think about those molecules. In a gas, we have the molecules that are spread out. Liquid, they're still flowing. It's a fluid. And so there's space. And then solid, they're arranged and compacted into a specific structure. So as we increase pressure, we start to push those molecules together, and an increased pressure at the same temperature. So right here at 0.01 degrees Celsius, it can be at a low pressure, it can be a gas. As we increase the pressure, we can turn it into solid. We squish those molecules together. And then as we move up, as the pressure increases, it turns to a water. All right, so pressure affects the phase of matter as well. So those are the two variables that you need to know and you need to be familiar with as far as what causes matter to change from water or liquid to gas, liquid to solid, or any combination of those. Right? So you should be able to, or you'll be able to use a triple point diagram to figure out, okay, if the pressure is this, 1 atmosphere, and the temperature is 100 degrees, then what state of matter, what phase of matter will that substance be in? All right. That's all for today. If you have any questions, you know how to get a hold of me.